Hey everybody, I wanted to spend a little bit of time talking about covalent bonding, and this is maybe a little more details um, about what happens when things covalently bond. Okay, and so if we draw the Lewis symbol of chlorine, okay, let's look and see what happens. Now, chlorine has 7 valence electrons. Okay, everything in this row in the periodic table has 7. These little handy dandy numbers at the top tell us how many valence electrons everything has. So this has 1, 2, 3, 4, 5, 6, 7, 8. Don't put the teen in there. Okay, so that's what happens there. But okay, so if we take a look at chlorine and its Lewis symbol, we have 1, 2, 3, 4, 5, 6, 7, and then we take chlorine here, 1, 2, 3, 4, 5, 6, 7. This electron is not paired. We have all sorts of paired electrons. And now let's see what happens here. These two chlorine atoms come together, they get close to each other, and then a funny thing happens. And so what I'm going to do here is I'm going to draw this. I'm going to take off those electrons, and in red I am now going to do this, but I'm going to do it backwards from the way that I normally do. And so if you look, these two chlorines can kind of push together, and they can share this electron, these electrons with each other. And so that gives them a total of 8 electrons when they share that. Let me show you how that works. Okay, this chlorine here has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7. And I'm going to has 7 valence electrons. And I'm going to draw it backwards to illustrate what's going on here. When you draw these enough, you just it'll it's fine to draw them backwards. You'll be able to draw them that way. I don't really know what I'm saying, but okay, brain fart. So I'm going to draw this the correct way. 2, 3, 4, 5, 6, 7. Now if we look, the red chlorine has how many valence electrons? 2, 4, 6, 7, 8. And the black chlorine has 2, 4, 6, 7, 8. These two electrons here are being shared. There's a sharing going on in the middle. And that is a covalent bond. When those electrons are being shared between the two, the orbitals that chlorine has overlap, and they share that. Actually, this happens so much that chlorine is found in nature not as Cl. You can't ever find Cl alone, but because of its electronic structure, chlorine is found as Cl2. Okay, and that's how we find it when we're looking for it out in nature. Okay. Now, let's do some sample problems here. And so if we look at nitrogen, okay, I'm going to do a nitrogen. 1, 2, 3, 4, 5. And now in red, I'm going to put hydrogen. Now remember, hydrogen is a little special. And so I'm going to put a hydrogen here. There's 3 hydrogens. That's what that 3 means. Okay, and I'm going to put a hydrogen here, and I'm going to put a hydrogen here. And so what I've done is I've put these together in a puzzle piece sort of form, where now if I look at the nitrogen, around nitrogen in the middle there is 8 valence electrons, and each hydrogen has its octet filled, duet filled, whatever you want to say, but it's full. Hydrogen only wants to have 2 electrons, so it's good. Okay, and so that is a covalently bonded compound. Water, H2O, this is ammonia, just to let you know. Okay, this is water here. Oxygen, 1, 2, 3, 4, 5, 6. And then hydrogen, 1, hydrogen, 1, fits together like a puzzle piece. Okay, if I look at oxygen, has 2, 4, 6, 8 valence electrons, has 8 electrons, its octet is full. If we look at hydrogen has 2 valence electrons, its octet is full. Okay, so now let's take a look at this guy. This is carbon tetrachloride. Okay, this one's going to take a little bit longer, but carbon has 1, 2, 3, 4 valence electrons, and chlorine has 7. So we're going to go 1, 2, 3, 4, 5, but this one's already full now, 6, 7. Oh, look! Chlorine has now a completed octet. How many more chlorines would we need around the carbon? We would need 3 more for a total of 4. So this compound almost has to have this configuration, okay? Kind of neat how it all works out. So we put that in the middle. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay, same thing here. 1, 2, 3, 4, 5, 6, 7. Okay, so if we look at, and I'll just circle 1 chlorine. So that chlorine has 8. And this carbon, if we look at that carbon now has 8. Okay, its octet is full. Okay, so this is how the octet rule fits into covalent bonding. Okay, there's other options with covalent bonding. So one of those other options is something called multiple bonds. Okay, and so if we have something like oxygen, okay, O2, how many oxygens are there? That 2 means there's 2 oxygens, so we're going to put oxygen, we're going to put oxygen, and I'm going to draw this again kind of special because it illustrates my point. Okay, I guess I should make this red. So then this is going to go 1, 2, 3, 4, 6. So now, if we just share 1 electron, 1 pair of electrons, this now has 1, 3, 5, only 7 electrons. And now the one in red has only 2, 4, 5, 6, 7 electrons. So we have to share more than 1 pair of electrons, or more than 1 electron in set of electrons in order to make its octet full. So what we're going to do is now we're going to share 2 pairs of electrons. And so now if we draw that, look at what I'm going to do. I'm going to go O, I'm going to put 1, 2, 3, 4, and then I'm going to go 5, and then I'm going to put this one here, okay, and I'm going to draw it. It's not paired, but I'm going to draw it there because that's just kind of what's happening. And I'll take the red one over here. Okay, and I go 1, 2, 3, 4, and now 5, 6. And so now if we look at the red one, how many valence electrons are around the red oxygen? 2, 4, 6, 8. That has 8 valence electrons. Okay, 2, 4, 6, 8. The black one has 8 valence electrons. So we can make multiple bonds. Okay, this happens also in carbon dioxide, CO2. We'll put carbon in the middle. Carbon has 4 valence electrons. Okay, so it needs to somehow get 4 more electrons in order for its valence in order for its valence to be satisfied. While oxygen, we can go 2, 4, 6, and we can share these 2 and these 2. Okay, now we can do it on the other side, and we can go 2, 4, 5, 6, and we can share those 2 and those 2. And so what we end up with is 2 double bonds. So we have carbon in the middle with one that looks like this. Okay, and then carbon in the middle, which looks like this. Okay, so it's kind of interesting to see how these go. And so there's instead of 1 pair of electrons in there, now there's 2 pairs of electrons. So if there's 2 pairs, that's a double bond. Okay, when two electron pairs are shared between 2 atoms. Okay, and that's a double bond. We could also have 3 Okay. If there's 3, there's a triple bond. Okay. We don't go any more than 3. I mean, we can, but we don't in this class. So we just stay up to triple bonds. And so that's what multiple bonds looks like. So you can have covalent bonding, you can have single bonds and double bonds and triple bonds, and it's all because of sharing and the way that these puzzle pieces fit together. So that's cool stuff, and have a great night.